Today, what we're going to talk about is lesson 3-2, linear combinations, and ax plus by is equal to c. Okay? What you should all remember this from Algebra 1 as is standard form. And we'll talk about that in a little bit. Okay? When the sum of all multiples of x and y is a constant, then ax plus by equals c for all x comma y. So you can put numbers in there and get a linear equation. Okay? The form y equals mx plus b is convenient for graphing lines because of the y-intercept and slopes are obvious. But you have also seen many equations for lines in different forms. For an example, in the rectangle with length L, width W, and the perimeter's 20 inches, we say 20 is equal to 2 lengths plus 2 widths. Okay? This is a linear equation, and the expression 2L plus 2W is called a linear combination of L and W. A linear combination is an expression in which all variables are raised to the first power and are not multiplied or divided by each other. Linear combinations may have 2, 3, or 4 variables, which we are going to have to solve for. Activity. At Harry's Hamburger Hovel, hamburgers cost $2.50 and hot dogs cost $2. Suppose you have $30 to spend for hamburgers and hot dogs for a family gathering. Step 1 says, write an equation relating the number B of hamburgers and the number D of hot dogs you can purchase to spend all the money. So, doing this, how much does a hamburger cost? Well, a hamburger costs $2.50, so it's 2.5 B. Because if I buy 2 burgers, then it's going to cost me $5. If I buy 3 burgers, it's going to cost me $7.50, right? Plus, how much does it cost for a hot dog? $2 times D. Okay. Those 2 burgers, the number of burgers and the number of dogs are my 2 variables. And the most money I can spend is $30. So, after I buy my burgers, number of burgers and number of dogs, the most I can spend in total is $30. Okay? Step 2 says solve the equation in step 1 for D. So what I need to do is get D by itself. So in doing this, I need to move 2.5b to the other side, so I'm going to subtract it. So it leaves me with 2d is equal to 30 minus 2.5b. Okay. The inverse of multiplying is dividing. Okay. So I got to divide by 2. So I got to divide everything by 2. When I do that, D equals 30 divided by 2 is 15 minus 2.5 divided by 2 is, you all should be telling me, 1.25, and then we have our B on there. Don't let that go. So we solved for D. Okay? Perfect. Step 3 says graph the equation in step 2 without taking the real world context into account. Okay? If we do that, look right here. We have it graphed for you. What's my y-intercept? My y-intercept is 15. Okay? Then I go down 1.5 over 1 and keep doing that. So they graphed this for us. Okay? Notice I have a y-intercept right here. I have an x-intercept, which is right here. What does that stand for? Well, this y-intercept stands for the number of hot dogs. Okay? And as you can see right here, they have number of hot dogs, number of hamburgers. Okay? What happens is, if I bought 15 hot dogs, 2 times 15 is 30. Okay? That means I would have 0 hamburgers. Or, if you look here, I could buy 12 hamburgers, but then I would have 0 hot dogs. Okay? Or if you meet here, I could buy 5 hot dogs and looks to be about 8 hamburgers. Or I could buy 4 hamburgers and 10 hot dogs. Why do we have this? It says in step 3 of the activity, you should have found that the graph of the equation is a continuous function. We just went ahead and drew the graph. The domain and range are the sets of real numbers, which is fine. However, the entire line as shown at the left below is not an appropriate graph of the situation because counts of hamburgers and hot dogs are whole numbers. Okay? We can't graph, you can't buy 2.5 hot dogs or 2.5 hamburgers. You can only buy whole numbers, which is why this graph right here, this linear function, is discrete. X and Y must be non-negative integers. Okay? They must be non-negative integers. You can only buy 15, 0, or what looks to be 10, sorry, not 10. I got those mixed up. 0, 15, or 4, 10. That means you have hamburgers to hot dogs. So 0 hamburgers, 15 hot dogs. 4 hamburgers, 10 hot dogs. 8, 5, and 12, 0 are the 4 possible outcomes that would make this situation true. In example 1, give 2 different situations that could be modeled by the linear combination equation 6x plus 3y equals 30. For each situation, state whether the linear function is discrete or continuous, and explain what the point 3, 4 represents. Okay? If you look at this, something that we could say is we ran, or we could say, yeah, we ran for 6 miles per hour and walked 3 miles per hour for a total of 30 miles. Okay? What does that mean? Okay? Well, X would be the number of hours we ran. Y would be the number of hours that we walked. So for point 3, 4, that would satisfy this equation, we ran 3 hours. We ran 3 hours at 6 miles an hour and walked 4 hours at 3 miles per hour. Okay? Another thing that we could use. Now, in this case, could we walk for 2.5 hours? Sure. Could we run for 2 1/8 hour? Yes. So this would be a continuous function. Okay? It would be a continuous function. Another example, 2 different situations. We could say an adult concert ticket costs $6. Concert $6 plus a child's concert ticket is $3, and we spent $30. and spent $30. So what does that mean? Well, that means what does 3, 4 mean for this instance? That means we bought 3 adult tickets and 4 child tickets. And it cost $30. Now, since we can only buy whole number of tickets, I mean, you can't have 2.5 adults or 4.5 adults, then this function would be discrete. Okay? The equation 6x plus 3y equals 30 is of the form ax plus by is equal to c, with a equaling 6, b equaling 3, and c equaling 30. When a and b are not both 0, the equation ax plus by equals c is called standard form of an equation of a line. Linear equations commonly occur in chemistry. For example, chemists describe the concentration of a solution in terms of the number of moles of the substance per liter. Mole per liter. 1 mole of a substance is approximately 6.02 times 10 to the 23rd molecules. So, for an example, 2 liters of a solution of 5 moles per liter hydrochloric acid contains 2 liters times 5 mole per liters equals 10 moles, or about 6.02 times 10 to the 24th molecules of hydrochloric acid. Although a well-equipped lab usually stocks solutions in various concentrations, a chemist often has to mix his or her own solution at a particular concentration by combining other stock solutions. Pharmacists, painters, and others who deal with mixtures use the same mathematics. This mathematics is not hard. You just need to know how to write the problem. So example 2. Suppose a chemist wants to mix X liters of 2.5 mole per liter solution of acid with Y liters of 7.25 mole per liter solution to obtain a mixture with 10 moles of acid. So my equation is going to be, how many of the first molecule solution do I have? Well, it's 2.5. So I'm going to call that 2.5, and I don't know how much I need, so that's going to be my X. X is the amount of 2.5 mole per liter solution I need. Plus, I have 7.25 mole per liter solution, and I don't know how much of that I need. So that is going to be my Y, because it's not going to be X because I need a different amount. Okay, because this is 7.5, this is 2.5. I want to obtain the mixture of 10 moles of acid. So I want to mix 2.5 and 7.25 to give me 10 moles of acid. It says how many liters of the 7.25 mole per liter solution must be added to 1.3 liters of the 2.5 to get 10 moles of acid in the final mixture. Answer to the nearest 0.1. So they just gave me my X value. It's 1.3. So I'm going to take 2.5 times 1.3. And I'm just going to do this by hand instead of putting it on the calculator. Hope that doesn't bother you. So I need to take 2.5 times 1.3, and that is 3.25 plus 7.25 times y equals 10. So I'm going to subtract 3.25 because all I'm doing right now is solving for y. So I get 7.25y is equal to 10 minus 3.25, you all should be telling me, is 6.75. And if I divide by 7.25, My Y is going to be 0.93, and they just want us to go to the 0.1, so 0.9 liters. Okay, 0.9 liters. So, in order to get a 10 mole solution that contains 1.3 of my 2.5 mole per liter solution, is only going to take 0.9 liters of 7.25 mole per liter solution. Hope you enjoyed that. We'll see you tomorrow.